Now that we're comfortable thinking about functions as describing a relationship between changing quantities, it's time for us to be able to put a specific number to that notion of change. In what ways can we measure just how quick the change is that's being represented by a function? That's what you're going to look at in this section called the average rate of change. The average rate of change is an answer to the question, between two different points, what is the overall change rate that's being represented? So here's an example. Suppose that I'm swimming laps. I do one lap out and back from the starting blocks in a swimming pool. I can measure a relationship between the amount of time that's elapsed in seconds and the distance that I am from the starting block, measured in, let's say, meters. So as an example, at t equals 0 seconds, I'm on the starting block, and so that corresponds to a distance of 0 from the start. And then maybe 5 seconds later, I've covered a distance of 20 meters from the beginning. And 45 seconds later, I've covered 50 meters, so I've made it all the way to the opposite end of the pool. At the 75-second mark, maybe I'm back at 30 meters from the starting block, and maybe at 100 seconds, I'm back where I started from. So I've done my lap in 1 minute and 40 seconds. I can't swim that fast. Maybe you can. So here I have a relationship, and I can ask the question, how fast was I swimming? The problem with that question, though, is it's not very specific, because I might have been swimming different speeds at different points in time. And when we measure an average rate of change, we have to be more specific. By saying something like, how fast was the swimmer swimming during the interval from 0 seconds to 45 seconds, let's say. In the first 45 seconds, on average, how fast was this person swimming? And so what that's doing is it's picking out 2 points in time. 2 instances in this relationship, 2 data points from the table, or 2 points on a graph, 2 values of t and their corresponding values of the distance d. So what could we say? Well, in this time interval, the amount of distance that was covered is 50 meters, because that's 50 meters here minus 0 meters there. And that distance was covered over an amount of time, which we can measure by subtracting 45 seconds, which was my ending time, minus 0 seconds, which was my starting time. So this swimmer covered 50 meters in a period of 45 seconds. So how fast were they swimming? What would rate mean in this context? Well, rate is always a ratio of output values per unit change of the input values. So in this example, that rate is going to be my number of meters that I covered divided by the number of seconds that it took me to cover them. So how fast was I swimming over this period of time? 50 meters divided by 45 seconds. I can reduce that fraction, 10 over 9 meters over seconds. As a decimal, it's 1.111 repeating, but that number, 1.1 meters per second, is what we're going to call an average rate of change. It tells me how quickly my dependent variable changes in response to changes in my input variable. So, our definition in this section of average rate of change of any function f of x on an interval of x from a to b is just the difference in the output values, f of b minus f of a, here 50 meters minus 0 meters, divided by the corresponding difference in the input values, the b minus the a, 45 seconds minus 0 seconds. That's what we're going to call the average rate of change of the function over this interval. That's how to think about it in terms of a formula and how to think about it in terms of data. We can also think about it graphically, because the average rate of change of a function can be seen on its graph as the slope of the line segment that joins those 2 points on the graph. So if I want to know what the average rate of change looks like, just take whatever 2 points that we're asking about on the graph, connect them with a line segment, and find the slope of that line segment. That's all. Average rate of change is a slope. And keep in mind that in general, that slope can be very different if I choose different points on the graph. When I chose these 2 points, the average rate of change was 1.111 meters per second. But you might imagine that if I choose 2 different points, let's say this one and that one, that I'm going to get a very different number for my average rate of change. In this example, for these 2 points, it looks like the average rate of change would be a negative number because the slope of this line segment is negative. So most important in this section is to be able to understand an average rate of change from all these different perspectives. From the perspective of data, where we take a difference in the output, divide by the corresponding difference in the input, and when there are units on those quantities, keep those units with you so you know what this average rate of change means. On a graph, average rate of change is the slope of a line segment. We call it a secant line next semester in calculus, but let's not worry about that for now. A line segment joining 2 points on the graph. The slope of that line segment is what we call the average rate of change of the function on that interval. And then from the point of view of formulas, the average rate of change of f of x is nothing more than the difference in the f of x values, f of b minus f of a, divided by the corresponding difference in the x values, b minus a. It's just rise over run. It looks just like the slope formula because it is a slope at the end of the day. That's average rate of change.